So for type 1 region, the way of evaluating the limit is, so you need to draw a vertical line, രണ്ട് points intersect ചെയ്യും. So lowermost point of intersection will be on the curve y equal to g1, and the uppermost point of intersection will be on the curve y equal to g2 of x. So that will be the y limits, and move the vertical line from to the leftmost point and to the rightmost point. So the point where the vertical line intersects the leftmost position of the region R, that will be the left limit of, that will be the limit x equal to a, and the rightmost point direction x equal to b. So that's how we form the limits in the case of type 1 region. So let us look at an example of finding the limits for the type 1 region. So we need to evaluate the integral over region R x by dA, where R is a region which is enclosed between the curves y equal to x by 2, y equal to root x, and the lines x equal to 2 and x equal to 4. Now നമുക്ക് region ആണ് തന്നിട്ടുള്ളത്. ആദ്യം നിങ്ങൾ അതിൻ്റെ region rough ആയിട്ട് sketch ചെയ്യുക. So we have the line y equal to x by 2 and y equal to root x. So y equal to root x will be the upper portion of the parabola, y square equal to x. So that will be this portion of the parabola, and y equal to x by 2 will be this line. Okay. And now let us look at the point of intersection. So the point of intersection of x by 2 and y equal to root x is x by 2 equal to root x, so that implies x square by 4 equal to x. So that is x square minus 4x equal to 0, so that implies x is equal to 0 and 4. Now when x is 0, y value is also 0. So the first point of intersection is 0, 0, and here x is equal to 4 and corresponding y value is 2. So നമ്മുടെ lines ഇതായിരിക്കും rightmost line. So on the right side it is bounded by x equal to 4, and the line x equal to 2 will be somewhere here. So this is our region. So our required region of integration is bounded above by, this is y equal to root x, and this is y bounded below by y equal to x by 2, and on the left by x equal to 2 and x equal to 4. അപ്പോൾ നമ്മൾ vertical line എടുക്കുമ്പോൾ vertical line മുകളിൽ intersect ചെയ്യുന്ന curve root x ആണ്, താഴെ intersect ചെയ്യുന്ന curve x by 2, and line ഇങ്ങോട്ടേക്ക് ലെഫ്റ്റിലേക്ക് മൂവ് ചെയ്യുമ്പോൾ ടച്ച് ചെയ്യുന്ന minimum point x equal to 2 and maximum point is x equal to 4. So that gives the limit of integration. So y will vary from x by 2 to root x, and x will vary from 2 to 4. So therefore y varies from x by 2 to root x, and x will vary from 2 to 4. So therefore double integral over r xy dA will be equal to integral 2 to 4 integral, we'll get x by 2 to root x xy dy dx. So this is the variation of y and this is the variation of x. So upon integrating we'll get x y square by 2 from x by 2 to root x dx varum. So that is integral 2 to 4 x by 2 into y square limit apply. So we'll get x minus x square by 4 dx. So that is integral 2 to 4 x square by 2 minus x cube by 8 dx. So upon integrating you will get x cube by 6 minus x raised to 4 by 32 from 2 to 4. So apply the limits from 2 to 4. So we get 64 minus 8 by 6 minus 1 by 32. And 4 raised to 4 is 256 minus 2 raised to 4 is 16. So upon simplifying, we will get 11 by 6. So that is the required value of the integral. How we evaluate the limits in case of type 1 region. Now, similarly, let us look at the evaluation of type 2 region. Now, type 2 region എടുക്കുമ്പോൾ type 2 region will be of this form. So on the left and right you will have the curves h1 of y and h2 of y, and above and below you have, so this is y equal to c and y equal to d. Okay. And now the same way നമ്മൾ type 1 vertical line വെച്ചാണ് start ചെയ്ത്. So here you draw a horizontal line inside your region. So the horizontal line will intersect the region at 2 points. So the leftmost point will be on the curve x equal to h1 of y, and the rightmost point will be on the curve x equal to h2 of y. So that will give the x limits. So x will vary from h1 of y to h2 of y. ഇനി അതുപോലെ നമ്മൾ എടുത്ത ഹൊറിസോണ്ടൽ ലൈൻ താഴേക്ക് അത് മൂവ് ചെയ്യുക, ദെൻ മുകളിലേക്ക് മൂവ് ചെയ്യുക. താഴെ റീജിയനെ ഇന്റർസെക്റ്റ് ചെയ്യുന്ന ഏറ്റവും മിനിമം പോയിന്റ് ഏതാണെന്ന് നോക്കുക. സോ ദാറ്റ് വിൽ ബി ദി limit y equal to c, and move it upwards, and the highest point where the line intersects the region R will be y equal to d. So that will give the y limits. So നമ്മൾ type 1 ചെയ്ത പോലെ തന്നെ, so instead of starting with vertical line, start with the horizontal line. But we'll get the limits of x first in terms of y, and then we'll get the limits of y to be constant. So that is how we set up the limits for type 2 region. So let us see an example for type 2 region also. To evaluate double integral over R 2x minus y square dA over the triangular region R, which is enclosed between the lines y equal to minus x plus 1 and y equal to x plus 1 and y equal to 3. Let us first draw the triangular region. So we will be obtaining the region in this form. So this will be the line x plus y equal to 1. Then you have the line y equal to x plus 1. So that will be this line. Okay. Y equal to 3 here, and the point of intersection y equal to minus x plus 1 and y equal to x plus 1 is minus x plus 1 equal to x plus 1. So that will give, so we'll get 2x equal to 0. So we'll get x equal to 0. So x is 0, and when x is 0, y is equal to 1. So the point of intersection is the point 0, 1. So this is the line y equal to minus x plus 1, and this is y equal to x plus 1. Now this is our region R. The step 1 is to draw a horizontal line which is passing through the region R. So the horizontal line will be intersecting the given region at 2 points, and the leftmost point will be on the curve, that will be x equal to h1 of y. ഇവിടെ x എന്ന് പറയുന്നത് we will get 1 minus y, and the rightmost point will be, because we are moving in this direction, അപ്പോൾ നമ്മൾ x എവിടെ തൊട്ട് എവിടെ വരെയാണ് വേരി ചെയ്യുന്നതാണ് നമ്മൾ നോക്കുന്നത്. So here you will get x equal to h1 of y, and on this portion we will have x equal to y minus 1. So therefore x varies from 1 minus y to y minus 1, and we move the line downwards, താഴേക്ക് move ചെയ്യുമ്പോൾ, so the minimum value of y you get is y equal to 1, and the maximum value you get inside the region is y equal to 3. So therefore y varies from 1 to 3. So that is the limit of integration. So let us now evaluate the integral. So therefore double integral over R, 2x minus y square dA will be integral 1 to 3, then the limits will be 1 minus y to y minus 1, 2x minus y square. So we will have dx dy. So this is the limits for x, and this is the limit for y. So we get integral 1 to 3. So first integrate with respect to x. So we'll get x square, 2x into integral x square varum, minus y square is considered as constant, so integral will be x. So it varies from 1 minus y to y minus 1 dy. Now applying the limits, we will get y minus 1 whole square minus 1 minus y whole square minus y square into y minus 1 minus 1 minus y dy. Now y minus 1 whole square will be same as 1 minus y whole square. So the first value is going to be, this difference will be 0. So we will be getting remaining integral 1 to 3 minus y square into, so here you will get 2y minus 2 dy. So that is minus 2 y cubed by 3 plus 2. Integrating now, minus 2 y cube in integral y raised to 4 by 4 varum, plus 2 y cube by 3 from 1 to 3. So that is minus 1 by 2, 3 raised to 4 is 81, minus 1 varum, plus 2 by 3 into 27 minus 1. So that is minus 40 plus 52 by 3. So the required value will be minus 68 by 3. So that is the required value of the integral. We evaluate a type 2 integral. ഇനി same integral നമുക്ക് type 1 ആയിട്ട് വേണമെങ്കിൽ evaluate ചെയ്യാം. പക്ഷെ type 1 ആയിട്ട് evaluate ചെയ്യുമ്പോൾ here what happens is, നമുക്ക് ഈ റീജിയനിൽ ഈ പോർഷൻ എടുക്കുമ്പോൾ താഴത്തെ കർവ് മൈനസ് എക്സ് പ്ലസ് 1 ആണ്. ദെൻ ഈ പോർഷനിലേക്ക് വരുമ്പോൾ താഴത്തെ കർവ് എക്സ് പ്ലസ് 1 ആണ്. സോ വെൻ യു ഇവാലുവേറ്റ് ദിസ് ആസ് എ ടൈപ്പ് 1 ഇൻറ്റഗ്രൽ, സോ വിൽ ഗെറ്റ് സം ഓഫ് 2 ടൈപ്പ് 1 ഇൻറ്റഗ്രൽസ്. അപ്പോൾ ആദ്യത്തേൽ മൈനസ് എക്സ് പ്ലസ് 1 തുടങ്ങി 3 വരെ ആയിരിക്കും y വേരി ചെയ്യുന്നത്. ഇൻ ദ സെക്കൻഡ് വൺ എക്സ് പ്ലസ് 1 to 3, and the x limits will be from this point to this point, and from x equal to 0 to this point.